Hello friends, welcome back to my channel. Today I'm going to show how to do recrystallization of your crude product as a pure solid. Here is a video I'm sharing which is a crystal growing in acetonitrile. So I used 100% acetonitrile to grow this crystal, and ultimately I got the 100% pure compound. So actually, in organic chemistry research, recrystallization is a miracle purification technique because it will save you time and effort not to do column. So many of us may know the techniques and solvent choices. Still, I'm gonna say a little bit about it. So normally non-polar or slightly polar compound can be easily recrystallized from acetonitrile. Sometimes you may add 1 to 2 milliliter DCM in acetonitrile and leave it overnight. You will get this kind of crystal. Sometimes leave in refrigerator. You might get the crystal again. In many cases, compound can be soluble in acetonitrile. In that case, you cannot do the recrystallization from the acetonitrile. But for compounds which have many aromatic rings, normally do give the crystal in acetonitrile, and sometimes you may add little bit DCM to just to dissolve in acetonitrile. And if acetonitrile doesn't work, then try with ethanol. So sometimes ethanol gives you a very nice crystal. First try regular ethanol, like that is 95%. If not, then try with the absolute ethanol, that is like 100% ethanol. Then if it doesn't work, sometimes it also need a little bit of DCM or chloroform. Sometimes methanol and chloroform is a very good choice. In many cases, you can just try with the regular normal hexane. If hexane doesn't dissolve completely, then add little bit DCM in it and then heat it up and keep it in room temperature, then you'll get the nice crystal. If you have a polar group like alcohol, solid amine or amide, solid ester, I know, yes, all esters are liquid normally, but there are some esters are solid. So try with hexane or haptane or pentane or cyclohexane to do the recrystallization. Many aromatic ring containing compound in dichloroethane also gives good crystal. Sometimes in toluene you can also get the crystal. In many cases, this is weird, but I have grown some crystal in THF. That is rare, but it is possible. So you have to dissolve your compound, heat it up in THF and leave it for room temperature maybe couple of days. Then you will get crystal from THF. So I have also grown a crystal, X-ray crystal structure from carbon disulfide. Yes, it is smelly and also it is kind of carcinogenic, but careful. Sometimes if you have many aromatic ring and or buckyball type things or like helicine type compounds, then you can grow crystal from carbon disulfide, CS2. So there are many other things you can consider for the crystallization and recrystallization. So you have to think about the solvent polarity also. So it may help you to choose the solvent for chromatography as well as recrystallization. So solvent, here I am showing some solvent list where the polarity decreased as you go down. So the most polar solvent is water, and then amides like N-dimethyl formamide, and also there is another solvent DMA, dimethyl acetamide, and then alcohols, methanol, ethanol, nitrile, acetonitrile, ketones, acetone, methyl, ethyl, ketone, esters, ethyl acetate, chlorocarbons, that is methylene chloride or DCM, and chloroform, ethers, diethyl ether, aromatics, you can think toluene, and alkanes, hexane, petroleum ether, pentane, haptane. There are some other things also you can consider for the recrystallization or purification of your compound. Suppose you did a reaction with NBS for bromination purpose in aromatic rings or polyaromatic hydrocarbons, and after the reaction of NBS you might get the residue succinamide, like bromine is used up but the impurity as a succinamide or like unused NBS. So in that case, first try your crude sample, check the TLC. If you see like it is moving with hexane very nicely or quickly, that means you can say your compound is soluble in hexane. So if your compound is soluble in hexane, then you can use hexane and dissolve your compound. And interestingly, the residue from NBS or like succinamide doesn't dissolve in the hexane. It will stay as a solid, so you can filter out the liquid, and that liquid should have your compound. So this is one of the way you can remove the succinamide residue from NBS reactions. And if your compound is not soluble in hexane and also is not completely soluble in acetonitrile at room temperature, then you can heat your compound in acetonitrile, and if you see this is soluble in hot situation, then you can do it, because if you do that, then it will grow crystal like this, white solid or like whatever the color. But the funny thing is the NBS or like bromo or like residue from NBS like succinamide can dissolve in acetonitrile. So your impurity will stay in the liquid acetonitrile, and you will get your crystal solid as your product. In many cases, after doing bromination with bromine, sometimes you might have some excess bromine, so you can wash. If your compound is solid and is not soluble in methanol or ethanol, so you can wash your crude with ethanol. It will take out your bromine. In many cases, you can dissolve your crude compound in DCM or like ethyl acetate, and then you can wash your crude compound by 10% sodium thiosulfate solution or sodium bisulfite aqueous solution. It will remove excess bromine, and iodine will be taken out by sodium thiosulfate. So today that's it. I will bring more tips for any other chemistry or techniques. Till then, stay safe, and who didn't subscribe my channel yet, please subscribe, and who already have subscribed, thank you for being with me and with my channel grow. Bye now.